I welcome you all for this lecture series on 4G and 5G communication networks. In this lecture number 17, we will briefly discuss about 5G network slicing. The network slicing is a technique used in telecommunications that allows multiple virtual networks to be created on a shared physical infrastructure. That is called network slicing. Each slice can be customized to meet specific requirements in terms of bandwidth, latency, and functionality, catering to diverse applications such as IoT, mobile broadband, and mission critical communications. This flexibility enables operators to efficiently allocate resources, enhance network efficiency, and improve service delivery while ensuring isolation and security among different network slices. So, network slicing is a key component of 5G technology, facilitating the delivery of customized services for various industries and user needs. First, we will see the overview of 5G. The 5G or fifth generation mobile network technology represents a significant leap forward in telecommunications, all you know that. And it is designed to deliver a reliable and enhanced user experience across a diverse range of applications. Unlike 4G, which primarily focused on improving mobile broadband speed, 5G offers a more versatile platform capable of supporting various use cases, including massive IoT connectivity, ultra reliable low latency communications and high bandwidth applications. This advancement enables service providers to create a new services and business model that cater to the evolving needs of consumers and industries and paving the way for innovations such as smart cities, telemedicine, and immersive virtual reality experiences, and it has got some diverse applications. So the first one is the smart metering. In the realm of smart metering, 5G facilitates continuous data transmission from thousands of utility meters devices, providing real-time monitoring of the energy consumption. While this application is not particularly latency sensitive, so it is not particularly the latency sensitive. It demands high scalability to accommodate the massive number of devices expected in smart cities. With the 5G's ability to connect a vast array of devices simultaneously, utility companies can efficiently gather and analyze consumption's data, leading to better resource management and more informed decision making for both providers and consumers. And next, if you are going into the autonomous vehicle, the integration of 5G technology in autonomous vehicle is transformative. All we know that it is a transformative technology as it provides the ultra reliable low latency communication necessary for safe and efficient operation. These vehicles require sub-millisecond response times to process and respond to real-time data from their environment, such as traffic signals, road conditions, and nearby obstacles. Additionally, autonomous vehicles generate and consume significant amounts of data, and it is necessary for high bandwidth for seamless operations. And by leveraging 5G's capabilities, manufacturers and service providers can enhance vehicle safety, optimize traffic flow, and create a more responsive transportation system, ultimately transforming the future of mobility. That's all about the applications of the 5G, the smart metering and autonomous vehicle applications are very, very important applications. Next, the challenges of while going for the network slicing, we are facing some challenges also. The challenges of the infrastructure, in infrastructure wise, the challenges, what are they? The rollout of 5G infrastructure presents several challenges, primarily due to the need to support a diverse array of use cases, each with its own unique performance expectations. Unlike previous generations of mobile networks, 5G must cater to applications that range from simple data transmission for smart metering to complex real-time communication for autonomous vehicles. This variety is necessary for the infrastructure and that can accommodate different requirements for especially bandwidth, latency, reliability, and scalability. As a result, network operators face the challenges of efficiency, managing resources, and ensuring that all users and applications receive the appropriate level of service, which is critical for the overall success and adaptation of 5G technology. So, in order to face this challenge, we are going for the network slicing. And to address the challenges of this 5G infrastructure, the 5G introduces the concepts of network slicing, a groundbreaking approach that enables the creation of multiple virtual networks on a single physical infrastructure. Each network slice can be tailored to meet the specific requirements of different use cases, ensuring optimized performance for each application. For instance, one slice can be dedicated to smart metering, focusing on scalability and continuous data transmission, while other can be designed for autonomous vehicles, prioritizing ultra low latency and high reliability. The flexibility allows network operator to efficiently allocate resources, and manage performance, ensuring that diverse applications coexist seamlessly and effectively on the same network, ultimately enhancing the user experience and facilitating the growth of innovative services. So that only we are going for this network slicing. Next, we should know the definition about network slicing. The network slicing is a technique that enables 5G providers to create multiple virtual networks on a single physical infrastructure, spanning from the radio layer to the core network. Each slice is customized with different speed limits, latencies, and quality of service configurations, allowing for the customized experiences based on specific application needs. And the end-to-end features, network slicing encompasses the entire architecture from RAN, Radio Access Network, to 5G Next Generation Core, that is NG Core. Each slice operates independently with its own configuration settings and performance characteristics, ensuring optimized functionality for various use cases while sharing the same physical resources. And this is the network slicing architecture. See how for each application it has been sliced. No? So the network slicing. So this is the diagram. One more time we can see network. This consists of various RN slice 1, slice 2, slice 3. Each slice is connected with the separate applications. We'll discuss in detail. So the network slicing allows different use cases such as smart meters and autonomous vehicles to operate on separate slices customized to their specific requirements. This optimization ensures that each application receives the necessary bandwidth, latency, and reliability, enabling efficient, effective service delivery. Next, enablers of network slicing. The implementation of network slicing is facilitated by technologies such as NFV, that is Network Functions Virtualization, SDN, Software Defined Networks, and Cloud Computing. These technologies allow for flexible allocation of both physical and virtual or logical resources, supporting the creation and management of distinct network slices within the radio and core network. Next, core network slicing. In the core network, each slice can run dedicated virtual network functions on the telco cloud, allowing for customized, no, services that aligns with the specific needs of different applications. This approach not only enhances service delivery but also optimizes infrastructure costs, making network operations more efficient and cost effective. Next, we'll move on to the network slicing capabilities and performances. So here, so if you are looking into the network slicing overview, the network slicing provides enhanced network capabilities, performance levels, and a specific service level agreement that we are calling it as SLAs, and it is adopted to various applications. This approach allows for efficient allocation of resources, ensuring that different services meet the required performance standards while maintaining the flexibility to adapt to changing demands. And the service mapping in the network slicing, services are mapped to network slice instant based on their specific capabilities, performance requirements, and SLAs. This enables a network slice to be dedicated to a single service for optimized performance or shared across multiple services, maximizing resource utilization. And if you are taking the example, for example, network slices are designed to support online gaming characterized by high bandwidth. Online gaming, if you are going for high bandwidth, is required and low latency, and it can be utilized for virtual reality services which require similar performance levels. Conversely, a slice aimed at web browsing, which is low bandwidth and latency insensitive, can simultaneously accommodate IoT analytics services, demonstrating the versatility, that is, demonstrating the network slicing. And the next is slice pairing. Slice pairing involves the mapping of radio access network, that is RAN, slice to the next generation core, NG core slice, ensuring the connectivity and performances. This function can be integrated into a network management system and operate as an application running on uh, top of SDN controller and facilitating efficient management and orchestration of network slices. Next, what is the necessity of going for or requirement for network slicing in 5G networks? First one is the dynamic configuration. The service providers must implement dynamic configuration and management of network slices to adapt varying customer needs to demands. This flexibility allows for quick adjustments in resource allocation and performance parameters, ensuring that each slice meets its specific requirements and requirements effectively. And independent management. To maintain optimal performance, each network slice must be managed independently, allowing service providers to fine tune settings and resources for individual slices without affecting others. This independence ensures that performance of one service does not compromise the quality of others. Next, security. It ensures ensuring security in is a paramount in network slicing as it involves protecting services and the data transfer over each slice. Service providers must implement robust security measures to safeguard against unauthorized access and data breaches, thereby maintaining user trust and compliance with regulations. Next, API exposure. Service providers should expose API, application programming interface. One more time, I'll tell you application programming interfaces to enable partners, vendors, and customers to create and manage network slices effectively. This accessibility promotes collaboration and innovation, allowing third parties to develop and integrate their services seamlessly into the network. Next, end-to-end resource management. Effective network slicing requires end-to-end resource management that encompasses the entire architecture from RAN, that is radio access network, to the 5G core. This comprehensive approach ensures that resources are optimally allocated and managed throughout the network, enhancing overall performance and efficiency. So this is about the requirement for network slicing in 5G network: dynamic configuration, independent management, security, API exposure, and end-to-end resource management. So this is the block diagram of network slice management. We have network slice, instant layer, resource layer, service instant layer, and we have pre-service or slice management and NMO, network management and orchestration plan. So we'll see one by one. So end-to-end management. Service providers manage network slice infrastructure across both RAN and the core, 5G core networks. And what this RAN structure do is, this RAN structure is divided into two distinct parts: the control plane and the user plane. The control plane manages signaling and control functions. No, yeah, and ensuring effective communication between network elements, while the user plane is responsible for handling only the data traffic, facilitating the transmission of user information across the network. Next, the configuration policies. Configuration policies for network slicing play a crucial role in provisioning and activating services across both the control and user planes. These policies dictate how resources are allocated and managed, ensuring that each network slice operates according to its designated performances, parameters, and quality of service, that is enhancing overall efficiency and the effectiveness of 5G networks. Next, layers of network slice management. So, layers of slice management network. What it will do is, the network slice management consists of three distinct layers that work together to provide comprehensive service delivery. All should work together. Service instant layer. This top layer consists of service instance that are exposed to customer and partners, including applications like IoT services, video streaming, and AR, VR. These services can be created and managed by network operators or third party providers, enabling flexibility and innovation. Next is network slicer, instant layer. The middle layer, see if you are looking into the this one, network in slice instant layer. So the middle layer consists of RAN slice instances and core network slice instances. So this one. And it providing the necessary network characteristics and adapted to each service instance. Importantly, a single network slice instance can be shared across multiple service instances, optimizing resource usage. Next, resource layer. The foundation layer includes the physical and virtual network functions necessary for creating and maintaining network slices. Resources in this layer may span multiple operator domains, facilitating collaboration and resource sharing among different service providers to enhance network efficiency. Next, network slice life cycle management. Network slice life cycle management. No, what it will do is, the network slice life cycle management plays a crucial role in coordinating with the NFV management and orchestrator, that is MANO, we can call it as, to manage virtualized network functions, VNFs, while also collaborating with other network managers for oversight of physical network functions, PNF. This MANO consists of key components: the NFV orchestrator, which oversees the orchestration of VNFs, and the VNF manager, responsible for managing the life cycle of VNFs, and the virtual infrastructure manager, which handles the management of the virtualized infrastructure. Automation is vital in this process, and it enhances end-to-end network slice management, improving user experience and reducing operational costs. Additionally, the deployment of SDN, software defined networking controller, significantly enhance management capabilities and providing APIs that enable service providers to develop applications for effectively managing network slices in wireless networks. So that's all about the network slice life cycle management. So it comes under this topic in interaction with NFV management, component of man, importance of automation, and the role of SDN controller. That means a software defined controller. And benefits. Benefits of network slicing. Cost reduction. It reduces the operational cost by enabling programmatic management of the network infrastructure through APIs and a dynamic MVNO management. And it simplifies the creation of configuration and management of mobile virtual network operator MVNO services, effectively reducing the need for complex manual pre-provisioning. This dynamic management enables quicker deployment of service and more agile response to market demand. And the differentiated services. It allows service provider to offer the customized services to customers on the same network infrastructure without compromising the performance for others. And example is supports both autonomous cars and smart utility meters simultaneously. And monetization opportunities. This is very important benefit. Moreover, network slicing opens up various monetization opportunities for service providers and enabling them to charge based on parameters such as latency, quality of service, energy consumption, and the number of connections rather than relying solely on bandwidth. This diversified approach to monetization helps provide us helps providers maximize revenue potential by creating to specific customer needs and the service requirements. And coming to the conclusion, network slicing is essential no, as a essential in 5G networks due to the diverse use cases in support. It supports ranging from Internet of Things application to autonomous vehicles and virtual reality, each requiring different levels of bandwidth and latency and quality of service. This capacity enables optimized resource utilization, allowing network operators to allocate specific resources for various services, which enhances overall network performance. Additionally, network slicing facilitates enhanced service differentiation, enabling service providers to offer customized solutions and it is additionally to individual customers' needs without negatively impacting the performance of other services on the same infrastructure. Finally, the automation of an efficient management of network resources provided by network slicing contribute to cost efficiency, reducing operational cost while allowing for dynamic provisioning here and the scaling of services to meet the fluctuating demands. So that's all about the network slicing of 5G architecture. So hence network slicing is essential for 5G networks as it enables the efficient management of diverse applications, ensuring optimal resource utilization and customized to service delivery. By allowing service providers to dynamically allocate resources, network slicing enhances user experiences while reducing operational cost. Hope everyone understood this topic, 5G network slicing. The remaining things we'll discuss in the next lecture. Thank you.